Or
I think Aniket is there, right?
No, it is started. Aniket,
I think
it
has
today
started.
morning, Sanket, I think. It
Oh,
started.
okay, yeah.
Started. Please go ahead.
Yes, it has started.
Sanket
Okay,
is here.
yeah, Sanket is here. Okay, great. So, again, good morning, everyone. I'm Dr. Mandar Badwe, and on behalf of Department of Technology and Savitribai Phule University, I welcome you all again for today's first session of this faculty development program on sustainability engineering. So our today's speaker for this session is Dr. Anaga Pathak. Dr. Anaga Pathak is a solar technologist. She is a faculty and coordinator for the Center of National Test Facility for Testing Solar Thermal Technologies and Technical Backup Center at Savitribai Phule Pune University. She has received prestigious Women Scientist Fellowship by DST for pursuing her doctoral studies. She was also involved in design, installation, and performance evaluation of solar thermal systems for product development at a reputed solar company. She was appointed as a senior technical officer for a joint project by Ministry of New and Renewable Energy and United Nations Development Program on concentrated solar heat. Dr. Pathak is a core member of the Bureau of Indian Standards. She is also passionate about working with upcoming and new talents, and she also mentors, new entrant students in designing quality solar products, which are made in India and which are accepted globally as well. Right. So for this, she hosts different teaching and training programs as well, and awareness presentations as well to carry out her work. Right. So it is my pleasure to introduce Dr. Pathak, and I hope all of you will enjoy her talk on solar energy and its applications. I sincerely hope her expertise in the field of solar thermal energy will definitely inspire all of us. So, Dr. Anaga Pathak, I think over to you.
Yes, I'll share my presentation.
Sure.
Should I share the entire screen or window?
I think the screen is better because that way we can see the full screen. So.
Okay, so is my presentation visible?
Not yet. I think the screen is not shared yet. So.
Wait a minute. It is hang. I think I'll rejoin.
Okay, yeah, no problem. Sir, do you have her presentation just in case?
No, sir, I do not have.
Okay.
She has not shared.
Okay. Yeah. Okay, we'll see, I think.
Madam, if required, you can just mail. We can do the presentation.
You're on mute, madam, so you can't hear.
I think I'm not allowed to share.
I think that shouldn't
It was
happen.
not there, madam.
Because I don't think you need any administration rights to present.
Yeah.
So the other option is that you can mail it. So some of us we can share.
Yeah, just try once whether you can give me the administrative approval for this, means authority to share my.
No, I don't think, ma'am, any sort of administration rights are required. I mean, even I am joined from my personal, and I can.
Because that share option I'm not able to click on. Yes, Dr. Adinath, you want to share something?
Ma'am, you can start sharing. Once you click that share screen arrow, you will be given 3 options: entire screen, window, and some specific tab.
I think I'm able to share now. Right?
Yes, madam. It's just perfect. Just go to F5, full screen mode.
Yes, I'll go to it. And in between, I'll keep my video off because of some network issue. So,
Sure,
Sure.
ma'am. Sure.
No issue. No issue.
Yes, great. Now it's perfectly fine.
okay, so a very good morning to all of you. I am Dr. Anagha Pathak. I am Assistant Professor in Center for Energy Studies and also Coordinator for the Testing and Technical Backup Unit of for Solar Thermal Technologies in Center for Energy Studies, Savitribai Phule, Pune University. So today I will be talking on the solar thermal technologies and its applications. Uh, so we need energy in our day-to-day life for various activities. So right from once we get up in the morning, we start our energy usage for various purposes. Like for cooking, we need energy for lighting, we need energy for heating applications, for air conditioning, transportation, and for industrial process heat and power requirement, we need energy. So basically, we need energy mostly in the form of heating and for electricity requirements. Um, so the use of energy has become an integral part of our lives. So its supply should be secure and sustainable. Wait a minute. Yeah. So the supply of energy should be sustainable. At the same time, it should be economical, environmental friendly, and secure. It should also be socially acceptable. The current trends in energy consumption are neither secure nor sustainable. Also, the rising consumption of fossil fuels, together with increasing greenhouse gas emissions, that is also one of the issues. It threatens the secure energy supply. The lack of sufficient energy supply can hold back the growth of any nation, as we all know. Um, the development of clean, secure, sustainable, and affordable energy sources should be our priority for the country. So the world energy requirement is continuously growing since the last few centuries and expected to grow further in future. So what are the driving forces? What are the main drivers for the increase in the energy demand? That it is the growth in world's population. As the population increases, the demand for energy also increases, and the techno-economic growth of the country is also taking place. So as both of these grow, the energy demand grows proportionally. There are various conventional or non-renewable energy sources which we are using for our energy requirements, to fulfill our energy requirements. The energy sources are considered non-renewable or conventional if they cannot be regenerated or made again in a short period of time. As we know that for the fossil fuel to be regenerated, it takes billions of years. And also it is going to deplete over time. We are all aware that the fossil fuels are depleting very fast. But the four non-renewable or conventional energy sources which are being used most often are oil and petroleum products, natural gas, then coal, uranium, or nuclear energy, you can say. So the increasing energy demand put a lot of pressure on the conventional energy sources, that is oil, gas, and coal. But the fossil fuel based energy sources are limited in quantity and also cause environmental pollution, that we all know. Therefore, there is a need for alternate energy sources which can provide us energy in a sustainable manner. So apart from the fundamental limitations of fossil fuels, the ecological considerations that are linked with the production of greenhouse gases and global warming. We all know that because of this greenhouse gases emission, the climate change is taking place, and as a result of that, the global warming is also there. The temperature of the planet is increasing. So that is why the role of renewable energy sources is very important, because it emits very less or almost negligible greenhouse gases. So excessive dependence on oil imports, unstable energy prices, and poor air quality, high levels of financial risks and uncertainty are other factors which are deterring the use of conventional energy sources. So now the time has come that, and already we have, our focus is, the government's focus is on the new and renewable energy sources. So what are the renewable energy sources? It is a natural source of energy which has unlimited supply, and the renewable energy sources that can be replenished naturally. Renewable energy can be used again and again, and it never runs out, unlike non-renewable energy sources. So what are the various renewable energy sources? Most of us know the solar and wind energy sources. So solar energy, it is in two forms. One is photovoltaic and solar thermal. Then bioenergy, biofuels, wind energy, hydro energy, and geothermal energy, also tidal energy. These are the various renewable energy sources. So we will see, uh, we are observing nowadays that the usage of renewable energy has increased. So what are the reasons for this? The higher prices of conventional fuels and the limited sources of conventional fuels, it has led to usage of renewable energy. Then there are user-friendly energy policies from our government. Government is promoting the usage of renewable energy, uh, and that's why we are now moving the environment, the user friendly policies have been created by the government, and the awareness to conserve fossil fuels is increased among the people, and it also reduces the emission of greenhouse gases, and it helps to control the global warming. Also, the availability of various renewable energy technologies. Nowadays, we have various renewable energy technologies available to us, be it the solar energy or wind energy or any other form of energy, renewable energy. Earlier, that was not the case. Very limited technologies were available. So today we will discuss about the solar energy technologies, what are available to us. First of all, let us, okay, my topics of this today's presentation will cover solar radiation, which is the important input for the usage of any solar thermal device or solar PV device, you can say. Then what are the various solar thermal technologies, the low temperature solar applications, medium temperature solar applications, high temperature solar application, and its integration. That is the most important thing, to use the solar technologies in an efficient way. So we all know that the sun is producing energy for billions of years, and solar energy is the solar radiation that reaches the earth. This energy can be converted into other forms of energy such as heat and electricity. The solar energy or the sunlight, you can say, is a very dilute source of energy, so it needs conversion in the usable form. So what are the various advantages of solar energy? It has abundant reserve, practically unlimited, available everywhere. Then it is a high quality energy, non-polluting, and it's a natural source, and energy security is also a factor. So we can see that it is the everlasting renewable source of energy, and being the clean energy source, no potential damage to the environment. Also, it is a very large source of energy, unlimited, available unlimited. Then it is free, available to all, unlike fossil fuel sources, which are concentrated at some location only. And this equitable availability it plays very important role in social development, especially in the developing country like India. There are certain challenges also. Like energy cost, you can say. producing electricity from renewable resources is more expensive sometimes, because the green technology does not have the infrastructure that the fossil fuels have developed over the years. And that's why to build the initial infrastructure, the cost is involved, and that's why the facility is expensive initially. Then energy, other limitations are, it is variable with time, it is variable place to place, not evenly distributed, low density, not directly usable, it needs conversion in some usable form. So utility companies can stock the sources like coal, oil to meet the ever-changing demand of electricity during peak demand hours. And most of the renewable energy sources cannot be stored for future use. We can use the solar energy as long as it is available, but its storage is difficult. So my colleague Dr. Adinath will be speaking about the energy storage in the next lecture, but still the storage is a factor of concern. So most renewable energy sources cannot be stored for future use, and the amount of energy generated depends on the availability of solar radiation. Therefore, a mechanism for effective energy storage and efficient recovery is required. Also, it has location dependency. As you see, the fossil fuel power plants can be placed almost anywhere as long as rail, road, or pipelines can reach the site. In contrast, the areas where renewable energy power can be utilized are limited. So, huge, it can be used where it is available abundantly. So, also, as I told you, the for new infrastructure, huge investment is also required. Uh, the solar collectors can be solar PV or solar thermal devices. Those are based on solar radiation. And that is the main input for these devices. And the technical and economical performance of these devices, it depends on the amount of solar radiation that is falling at a given location. And also at a given time. Therefore, the measurement and estimation of solar radiation is an important aspect of work. That's why I'm going to explain about the solar radiation, how much solar radiation do we receive, and what are the various losses, and also the about this solar radiation spectrum, and the measurement techniques for solar radiation. The amount of solar radiation intercepted by Earth, it depends on the distance between Sun and Earth. Since the Sun and Earth distance is not constant throughout the year, the amount of solar radiation that is intercepted by Earth also varies. As we all experience that the solar intensity of solar radiation is more in summer season than in rainy seasons and all. So that is because the Earth Sun distance is also changing due to elliptical orbit. Of course, this variation is not much. It is about 6%, and the Sun transmits energy in the form of electromagnetic waves. These electromagnetic radiations has a very broad wavelength range. You can see here in this figure. And it covers the portions of UV radiation, visible radiation, and infrared radiation. The spectrum of the sun can be estimated by considering the sun as a black body, and it has a unit of watts per meter square. So considering sun's temperature as 5250, now we consider it as 5760 Kelvin, and it is a spectrum of black body radiation. And if we plot this x-axis shows the wavelength range, and the y-axis shows the spectral irradiance. So here the y-axis is termed as solar or spectral irradiance, that is rate of energy that is received per unit area. And this per unit nanometer term, it comes from the fact that the energy flux is small wavelength range. Because of the large distance between sun and earth, the amount of solar radiation received on the earth's surface is quite low. So here this figure shows the extraterrestrial solar radiation also. Extraterrestrial is outside the Earth surface. And because of this distance, the solar radiation that is received on the Earth surface, here you can see, it is quite low. It is only 1367 watts per meter square, and this number is called as solar constant. So solar constant is measured at the surface perpendicular to the sun rays at the average sun earth distance that I will show in this figure. So various wavelength ranges, basic solar spectral regions are, here you can see ultraviolet 200 to 400 nanometers, visible 400 to 700 nanometers, and infrared 700 to 3000 nanometers. The solar constant is measured at the surface perpendicular to the sun rays, and it is measured and taken the average of throughout the year, measurement throughout the year. So due to the variation in Earth's distance, the amount of solar radiation that is received at the Earth's surface, it varies, that we have seen. Then the solar constant is the average value of the extraterrestrial solar radiation over a year. Then here you can see the term AM. So what is this AM? Air mass. At the extraterrestrial solar radiation, it is also known as air mass 0 because it has not traveled through the atmosphere. It is yet to travel through the Earth's atmosphere. So AM is considered as 0. And what is the air mass? The Earth continuously receives 174 into 10 raised to power 15 watts of incoming solar radiation at the upper atmosphere. When it meets the atmosphere, it reflects back the 6% of the irradiance, and the 16% of the radiation is absorbed. The sun rays outside the Earth's surface, they travel parallel to each other. Okay, and when the solar radiation passes through the Earth's atmosphere, it undergoes several interactions like absorption interaction or scattering interactions. And these interactions are with the gaseous molecules. Those are present in the atmosphere like carbon dioxide, ozone, or water vapors like that. So the interaction of solar radiation with the Earth's atmosphere is shown in this figure. So in the absorption interaction, the energy of the solar radiation is given to the gaseous molecules and other particles or pollutants that are present in the atmosphere. So this percent is around 16%, and due to the scattering interaction, here you can see, due to the scattering interaction, the direction of the sun rays changes. This results in redistribution of scattered radiation randomly. And it is distributed in all directions. So the scattered radiation is called as the diffused radiation. And the radiation which does not go through any of these interactions like absorption or scattering interaction, that reaches the Earth's surface directly without any change in the direction. So so this radiation is known as direct radiation or beam radiation, and this scattered radiation is known as diffuse radiation. So these are the important terms when you talk about the solar radiation. So once the radiation reaches the Earth's surface, some of it gets reflected by ground, and the objects which are present on the ground, those also reflect back the solar radiation. That is known as albedo radiation. So thus the total radiation that is reaching at a given point on Earth's surface, it is the sum of direct radiation, diffuse radiation, and albedo radiation. The percentage of albedo radiation is very low. That's why many times we ignore it. These terms are very important. Like I explained earlier, beam radiation or direct radiation, it is the solar radiation received at Earth's surface without change of direction and in line with the sun. Then diffuse radiation is the solar radiation that is received at Earth's surface from all parts of sky's hemisphere, and global radiation is the sum of beam radiation and diffuse radiation. So for you to understand this much is enough. Then there are certain other terms also, so we will not go in details. Then there are various solar radiation measuring instruments. In order to measure the global and diffuse radiation, an instrument is called as pyranometer is used. Here it is shown in this figure, pyranometer. So the direct solar radiation is, the direct solar radiation is measured with the help of pyrheliometer, and the global solar radiation is measured with the help of pyranometer. Normally, the temperature sensors are used in these instruments. The response of the temperature sensor is proportional to the light intensity which is falling on the sensor, and the signals from the sensors are then converted into solar radiation intensity equivalent readings, that is millivolt. And then thermocouple is used as a light sensor. Here there is a black plate, black absorber plate. One end of the thermopile is attached beneath this black plate, which gets heated when light falls on it, and the other end of the thermopile is kept in such a way that it does not receive any solar radiation. So due to this temperature difference, voltage is generated, and this voltage is proportional to the amount of solar radiation that is falling at this black plate. And how this pyrheliometer works, in this case the radiation sensor, it is placed at the bottom of this relatively long tube. The role of the tube is to reject the diffuse radiation and accept only the direct or beam radiation. So the tube receives a small amount of diffuse radiation that falls within the acceptance angle of this tube. And because of this arrangement, only narrow beam of direct radiation reaches the sensor, which is placed here at the bottom of the tube. So due to this, the tube should be accurately directed towards the sun. For this purpose, the tube is mounted on a 2-axis tracking device, so that all the times it should receive the direct solar radiation. So these are the solar radiation measuring devices. Here, just a minute. Okay, so here in this figure, you can see the solar radiation, intensity of solar radiation is low. We can feel it also, observe it also, that during the morning hours, the intensity of solar radiation is less. As the day goes on, the solar radiation goes on increasing with the time. It reaches to its peak in the afternoon, and then again it starts decreasing, and at the end of the day, again the intensity is very low, and during night hours there is no solar radiation. So this is typical curve of solar radiation over a day. So now let us talk about the solar energy. It is available to us in two forms. The one form is solar thermal energy. When it is converted to thermal or heat energy, solar energy can be used to heat water. That is, it can be for use in homes or buildings or swimming pools. Also, it can be used for heating spaces like inside the homes, greenhouses, other buildings. It is used for heating fluids for various industrial process heat applications. In our industries, most of the process heat requirement is in the range of 250 degrees centigrade, which can be easily fulfilled by using this solar thermal energy. And other applications can be cooling and cooking applications. Another form of solar energy, it can be used is solar photovoltaics. In this case, the photovoltaic cells convert sunlight into electricity. A photovoltaic cell, it is commonly called as a solar cell or photovoltaic cell, is the technology that is used to convert solar energy directly into electrical power. So a photovoltaic cell is a non-mechanical device. Usually it is made of silicon alloys. So we will be talking about this solar thermal energy part mostly today. So let us see how to use this solar thermal energy. So when solar radiation, now you understand what this solar radiation is. It is measured in watts per meter square. When this solar radiation falls on the solar collector, in the solar collector, there is a working fluid which is flowing through it. It gets heated because of this solar radiation and it is converted into solar thermal energy, which we can use for various applications. So this figure will make it more clear. This is the sun. The solar radiation coming from the sun falls on this solar collector. Mainly the solar collector is mostly painted in black color. As we all know that black color absorbs more heat. So the solar radiation once falls, this because of this black color and the absorber plate, the collector gets heated, and the water which is flowing or the working fluid which is flowing through this collector, it also gets heated. And when the water gets heated, its density becomes less and it goes upward. This heated water always goes upwards, and then we can take it out and use it in the form of thermal energy. So this concept is common for all the solar thermal energy devices. This is the working principle of any solar thermal device, you can say. Then how to use the solar photovoltaic energy. So solar radiation energy, when falls on the solar cells, it gets converted. This device converts this solar radiation energy into electrical energy. So you must have seen such type of photovoltaic installations. The mechanism of generation and other details my colleague will be talking, so I won't go into details. But when the solar radiation is incident on this solar cells, the positive electrons are collected near this p-type semiconductor and negative electrodes are collected in the near the n-type semiconductors. When the load is connected to it, the electric current flows through it. So there are basically two categories of solar thermal technologies. One is stationary collector or non-concentrating collectors. As the name indicates, it does not move or track. It is stationary or fixed in a position. So that is called as flat. Under these stationary collectors, there are flat plate collectors or evacuated tube collector systems. So these are basically low temperature range because no concentration is done there. Under evacuated tube collector systems, there are again various subcategories depending on the type of glass or the arrangement used, that I will explain in details in the upcoming slides. And another category is concentrating collectors. So in our childhood, all of you must have used the lens to burn the piece of paper. There we concentrate sun's energy on a single point and increase the intensity of solar radiation. By concentrating the solar radiation on a smaller area, which can burn the piece of paper that almost we have tried in our childhood days. The same concept is used in solar concentrators. So solar concentrators are tracked as per the movement of sun. The tracking can be in the east-west direction or in the north-south direction also. So depending on the tracking mechanism, if it is tracked only in the east-west direction as per the sun's movement, in a day, it is called as single axis tracking. And if it is tracked depending on the position of the sun in the sky, in the north-south direction also, then it is called as dual axis tracking system. So these are the various types of solar concentrators that I will explain in the next slides. But please now let me check whether I can show you a small video. It will explain in better. How these solar concentrators work. So are you able to, please let me know whether you are able to see this and hear this sound.
Yes, ma'am.
Availability of energy sources is the cornerstone of development for any country. In India, the ever-increasing demands exerted by the multiplying population, rapid urbanization, and progressing economy has led to serious shortages of energy. Dependency on fossil fuels is not only adding to the harmful greenhouse emissions in the environment, but their continuous depletion has led to an inconsistent rise in the fuel prices. Currently, the industries in India are relying too much on conventional sources of energy, which is proving detrimental both for the economy and the environment. We are on the verge of a serious energy crisis. But the answer to this energy crisis lies with the environment itself. Renewable energy. Renewable energy has proved its viability amidst the energy impasse. Renewable energy sources like wind, tidal, biomass, and solar are easily available, and technologies have been developed and proven to harness energy from these naturally occurring sources for various uses. Sun is the primary source of all forms of energy on Earth, and today, with the development of different technologies, it is possible to harness energy from sun. The solar photovoltaic technology, which converts the energy from sunlight into electricity, is quite a popular technology to harness sun's light energy. In contrast, the solar thermal technologies, which harness the thermal energy from the sun, are finding their prevalence in the industrial sectors for thermal energy requirements in various processes. Solar thermal technology involves two types of technologies: non-concentrating technology and concentrating technology. Non-concentrating technologies include water heaters, which are a common feature these days. The concentrating technologies have the capacity to generate high temperatures, which are required in industrial sectors like food processing, chemicals and fertilizers, pulp and paper, textiles and tobacco, etc., among other industrial and commercial establishments, which use thermal energy for process applications. These technologies can also be deployed for cooling needs in cold storages, dairies, where large-scale refrigeration is required. So how does concentrating technologies generate such high temperatures? In solar concentrating technologies, the incoming radiation is tracked by a reflective surface which concentrates the energy at a focal point, where the heat absorbers are placed. The absorber transfers the thermal energy to the working medium. These technologies are also capable of automatically tracking the sun's radiation, which is synonymous to a sunflower, which tracks the movement of the sun and always faces in its direction. The solar concentrating technologies can be divided into three categories: non-tracking concentrators, single-axis concentrators, and double-axis concentrators. Non-tracking concentrators. These types of concentrators remain static in a place and do not track the movement of the sun. Non-emitting concentrators are non-tracking type concentrators. Single-axis concentrators. Single-axis concentrators track the movement of sun along one axis, that is from east to west. The sensors automatically direct the concentrator to stay in the direction of sun to receive maximum radiation at all times during the day. There are three types of single-axis concentrators prevalent in India: linear Fresnel concentrator, parabolic trough, and Shaffler dish. Double-axis concentrators. Double-axis concentrators track the movement of sun along two axes, that is east to west, as well as the seasonal movement of sun. Fresnel paraboloid dish and parabolic dish has a double-axis tracking mechanism.
So we have seen how the solar concentrators work. So these are the various types of the solar concentrators. I'll explain it one by one. Why do we need these solar thermal devices that we already discussed for solar water heating, solar cooking, space heating and cooling, desalination, refrigeration and air conditioning, and industrial process heat. Also, solar thermal systems can be used for power generation, but for that, high temperature solar concentrators are required. So first we will see what are the low temperature solar thermal applications. Low temperature solar thermal applications means that the collectors or devices which can generate the temperature below 100 degrees centigrade. So the stationary collectors or non-tracking collectors, non-concentrating collectors can generate the heat or temperature below 100 degrees centigrade. And its applications are limited to solar water heating, solar cooking, solar drying, solar desalination, solar pasteurization, and space heating and cooling. So you must have seen such type of solar collectors on the rooftop of many buildings. So these are the very proven and popular technologies. One type is flat plate collector. As the name indicates, there is a flat plate. How it works, I'll show in the next slide. And another type is evacuated tube collector. The temperature which can be achieved using these collectors is around 70 to 80 degrees centigrades. And the life of system, although it is mentioned 15 years, it lasts for 20-25 years. These are the simple or maintenance free collectors, you can say, as there are no moving parts here. And the payback period is usually 4 to 6 years. Earlier, there were soft loan schemes by Government of India. Nowadays also there are very few schemes because this product is already been proven and there is no need of subsidy anymore. These are working efficiently and it's a proven technology now. So typically this is the flat components of flat plate collectors. There is a cold water tank through which the cold water enters to the header pipe of this collector, and these are the this is the absorber which is made of absorber fins. The fins are made up of copper, and below these copper fins there are riser tubes through which the water flows, and these absorber fins are coated with a selective coating. What is selective coating? It means when the solar radiation falls on it, it absorbs heat. So the absorptivity of this coating should be more than 90%, or it should absorb more heat. And as we all know, when we make chapatis and heat that hot plate, so and if we keep our hand above it, we feel heat. That means that hot plate is emitted the absorbed heat, emitting the absorbed heat. So the emittance of this absorber plate should be minimum so that maximum heat can be transferred to the fluid which is flowing through these riser tubes. So that is the meaning of selective coating. That means the absorptivity should be more than 90% and the emissivity should be less than 10%, 20%, you can say. There are various types of coatings which are available, like nickel, chromium, and other types, which improves the absorptance. So the flat plate collectors, they use both beam and diffuse solar radiation, and they do not require tracking of the sun, as they are low maintenance, inexpensive, and mechanically simple, as there are no moving parts. So what are the major components? There is a collector box which is made up of aluminum, and it is insulated from the sides as well as from the bottom with the help of glass wool or rock wool to prevent the convective heat losses. And this collector is inside this collector, there are absorber fins, which I showed in this figure or photograph. And above this assembly, there is a glass. So what is the purpose of glass? Many times, yes, we may think that to prevent the dust. That is true. But the main purpose of this glass is, as we see earlier in the solar spectrum, that we receive solar radiation in the form of electromagnetic waves. So glass is transparent for these short wave radiations, and when it passes through this glass, transmitted through this glass, uh, while re-radiating, it gets converted into long wave radiations. So glass is opaque for long wave radiations. So whatever heat it enters inside this glass collector, it gets trapped there. It cannot go back. So this is called as greenhouse effect. So that is the purpose of this glass cover. Yes, so this is a simple construction of this flat plate collector, and how it works. There are two types of circulation types. One is thermosiphon or natural convection. This is the flat plate collector, and this is the storage tank. So water enters from this inlet, and it gets heated through this flat plate collector. Heated water goes upward and it gets stored at the upper side of the upper level of the tank, and this circulation goes on until the required temperature is achieved in this whole tank. Suppose you want to heat the temperature, this flat plate collector can heat up to 70 degrees. So till then it gets circulated. And one thing we should remember, that if you use the water from the solar water heaters in the morning, you should maintain that cycle. Next day also you should use it in the morning, because you should allow that water to get heated. Many times what happens, people use it in the morning, then again they try to use it in the evening. So it doesn't get sufficient time for the water to get heated, and then people say, "Arey, isme se to garam pani aata hi nahi hai." So that is the reason why you don't get hot water sometimes. So if you are using it in the evening time, use it next day also. You should use it in the evening time, so it gets sufficient time for the water to get heated. So this is the thermosiphon type, and another type is forced or pump circulation. So this is possible for domestic application, natural convection, but when you are using number of such flat plate collectors, by gravity, the gravity flow is not enough. So in that case, you have to connect the pump which circulates the water through this flat plate collectors. It is connected in series as well as in parallel. Also, in some area, the water is hard water. So due to the hard water, the salts get deposited in the riser tubes. So to avoid this, the indirect heating system can be used. The fluid to be heated is kept here, and the water, it is in the closed loop. So it passes through this collector and this piping only, and the heat exchanger transfers the heat from this coils or water to the heat exchanger, transfers the heat to the water or fluid inside this tank. So this is a typical system. The cold water goes inside here in the header pipe, gets heated and goes upwards through these riser tubes, collected in this storage tank, and you can use it further. And many times in the rainy season, it works on the diffuse radiation, but then you will not get the required temperature. The temperature will be somewhat lower. So you need sometimes the backup water heater, which can be connected to your utility. So this is how the flatbed collector installation looks like. So it is very popular in hospitals, hotels, then hostels, like that. So another type is evacuated tube collector. Yeah. So mostly the tubes are imported from China. In India also, Borosil tried to make these tubes, but because of the volume, they didn't get sufficient volume. That's why it was not economical for them. So nearly 3/4 of the domestic hot water market is now captured by these evacuated tube collector systems. These are more popular nowadays because of certain advantages, and it can be used in natural or forced circulation. So here the problem of scaling is low because the tube diameter is also more, as well as it is made of glass. In case of flatbed collector, the riser tubes are made of copper, and its diameter is also less. So the scaling problem is more in flatbed collectors. However, the efficiency of flatbed collector is higher at lower temperatures, like till 50 degree or so. And then after, for higher temperatures, the efficiency of this evacuated tube collector is more because the losses are less in this case. How? I will tell in the next slide. So the various components of the evacuated tube collector are the storage tank, insulation, the tubes, evacuated tubes. There is a reflector for additional solar radiation to fall on these tubes, and the various and the structure. The glass tubes which are shown here are of various types. The most popular tube type is all glass tube type. So here there is a inner glass tube which is coated with the selective coating, and there is another outer glass tube, and in between these two tubes there is vacuum. So the solar radiation which is absorbed by this selective coating or inner tube, uh, and because of this vacuum, the convection and radiative losses are eliminated in this case. That's why at higher temperature it performs better. And another type of evacuated tube contains this U tube, copper U tube. So actual fluid is flowing through these tubes only, and the heat is transferred, the solar radiation which is absorbed, and the tube is heated. That heat is transferred to the fluid which is flowing through this U tube, and then the heated water is collected in the header pipe and taken out for usage. Another type is heat pipe based evacuated tube. In the heat pipe there is a certain liquid which gets vaporized at lower temperature. So as it gets heated and vaporizes, the it goes upward, and the heat is transferred to the fluid which is flowing through this header pipe. The water vapors get heated, goes upwards, and this part gets heated, and the heat is transferred to the fluid flowing through this. Again, the cooled vapor liquefies and returns to the bottom of the pipe to repeat the cycle. This is how the heat pipe based evacuated tube collector works. So we have seen about the solar water heater installations. Usually if you stay in the northern hemisphere, the collector should be facing to the south direction, and if you are staying in the southern hemisphere, then it should be facing north direction. So from this figure it is more clear that if you are in the northern hemisphere and it is south facing, then throughout the year you will get the solar radiation falling on this collector, and if you place it here you will not get the required solar radiation on the collector. So the some other applications are the residential hot water system. It's hot water generation, house warming, the coils through which the hot water passes, and then there is a blower which keeps the space warmer. Then large scale systems are used for dormitory hot water, swimming pools, industrial process heating, etc. So another device is solar dryer. So in the solar dryers are also of two types. One is natural circulation and another is forced circulation. So the working principle is same, but here, as you see, this is the collector, which is also painted black from inside, and there are small ducts here or holes here, and the air enters through these holes or ducts, and because of the black color it gets heated, and the hot air, because of low density, goes upwards, and in this cabinet there are perforated trays on which the material to be dried is kept, and the hot air while moving upwards removes the moisture from the product, and this is how it works. So another type is forced circulation type of dryer. Here, the collectors are placed on the rooftop, and the hot air, with the help of a blower, is given to this cabinet from the bottom side. And the hot air, while going upwards, it goes through these trays, perforated trays, and it removes the moisture from the product and dries the product. So this circulation takes place. So in the forced circulation type of dryer, you can get temperature up to 70 degrees centigrade, hot air temperature. But of course, depending on the moisture content of the product, the temperature will requirement changes. Another device is solar steel. So how does solar steel works? It is a rectangular, a square box which is painted black. It has given some angle here. Why? This box is filled up to 3/4 level by water, and due to the solar radiation and the heat absorption, the water gets heated, and it starts getting vaporized. And when the vaporization starts, because of the surrounding cool air in the atmosphere, it is condensed. The water vapors are condensed, and the droplets are deposited below this glass cover. And because of this angle or slanting glass, here there is a channel. The water is collected in the channel, and it is collected in the bottle. So in the military areas or many remote areas where potable water scarcity is there we can use this solar steel and get the distilled water or potable water. Another application of this solar steel is for salt pans. In the coastal area, for salt extraction, to increase the rate of evaporation of seawater, this solar steels are used. So of course there the installations are huge. Many such uh, solar desalination units are installed there, so that the rate of evaporation of water increases and the salt recovery is faster. So on all these products, there was a subsidy from Government of India initially, but now these products are popular, so subsidy is not required anymore. So this is the box type solar cooker. So most of you must have seen such type of solar cookers, which are very commonly used in most of the parts of India. The concept is same. This is the aluminum box which is painted black. There is insulation for reducing the convective heat losses. This is the glass cover. Here there is a double glass layer to prevent the radiative heat losses. The mirror is given so that the additional solar radiation falls on this box. And here there are pots in which we keep the material to be cooked. These pots are also painted black so that the pots also absorb heat and the cooking will be faster. So what are the advantages of box type solar cooker? All items can be cooked here, but you cannot do frying or you cannot make the chapatis. For roasting and baking, this is the most ideal product. the cooking is safe because the cooking is done at a slow pace. Then solar cooking is entirely non-polluting. The food tastes better because all the nutrients are retained. If you cook the food in the pressure cooker, most of the flavors and nutritions are lost with the steam. It is healthy, and if you test the food which is prepared in this solar cooker, you will feel the difference. The food is tastier and nutritious. Nutritions are retained in the product. And if a family of 4 or 5 members is using this cooker for baking and roasting and steaming requirements, then you can save up to 3 LPG cylinders annually as a result of solar cooking. The payback period is around 3 years, and the life 10-15 years it is written, but for 20-25 years people are using it. Then operation and maintenance cost is almost negligible. Another advantage is that unless you open the lid, the food which is kept inside, it remains hot. Then in the box type cooker, we have seen that the frying and chapati making we could not do. So this is the dish type solar cooker, which is a parabolic cooker. Whatever solar radiation falls on this parabola, as per the property of parabola, all the radiation gets converged at the focal point. So here the heat is more at this point focus. You can get almost 250 degrees centigrade heat. Here at the focal point, you can directly place the pressure cooker and you will get the whistles. If on your regular burner, gas burner, you are getting the first whistle after 15 minutes, here you will get it after 18 or 20 minutes. That is the difference. But it works very well. We have tried it, and earlier we are testing these products in Center for Energy Studies. We have a test center where we test various solar thermal products for the manufacturers to get themselves registered with Ministry of New and Renewable Energy. So while testing, we have also tried preparing various products in this cooker, and it works very well. The small size cooker can cook for a family of 6 members, and the cost is 10,000. Also, the bigger size cookers are available, which can cook for community purpose for 40 to 50 people. And you can, if you cook one batch, then you have sufficient time. If you get the rice cooked in 20-25 minutes, then you can take 3 or 4 more batches till the solar radiation is available to you. So the cooking vessel capacity is 30 liters for 2.5 meter diameter parabolic dish cooker. And these are the aluminum reflectors. The reflectors need to be changed after 3 to 4 years as the reflectivity gets decreased, or if there are certain dents, then the scattering is there and the focus will be scattered. So the heat which we get here will become less. The temperature will be less. So it needs changing the reflectors. And it is very ideal for NGOs, ashram schools, dharmashalas, and in many villages or rural communities, 3-4 families can use this cooker uh, in 3-4 batches like this. So these are the various types of solar cookers which are available and popular. Some are aesthetically also very good. Some rice cookers are so aesthetically so good that you can place it directly on your dining table. So this was all about low temperature solar applications. Now the medium temperature solar thermal application. So for medium temperature, we consider 100 to 250 degrees centigrade as medium temperature application. For that, concentrating collectors are required. Flat plate collectors will not be able to produce this much temperature. So for medium temperature solar thermal applications, various types of solar concentrators are used. So what is a concentrator? So I have shown you in the video how the solar concentrator works. The beam normal radiation, it works on beam normal radiation only. The diffuse radiation doesn't work for solar concentrators, because it will not be converged at the focal point, it will scatter somewhere else. So this beam normal radiation falls on the reflector. This is the aperture area of the reflector, and from there it is focused on a smaller receiver area. So as I told you, the lens principle, like this, the solar radiations are concentrated on a smaller receiver area, considering certain thermal losses, certain optical losses. Whatever heat we get, that is known as useful heat. And there is a term called as concentration ratio. That is the ratio of the effective area of the aperture to the surface area of the receiver, this area to this area. This is known as the ratio of these two areas is known as the concentration ratio. So more the concentration ratio, more is the temperature which we can get, because more point focus will be there. So why concentration is required? To increase the efficiency, to reduce the collection area? No, it is to get the increase in temperature. So reduced absorber area, reduced thermal losses, because the lower the area, the losses will be lower. From flat plate collector, the complete flat plate collector box and assembly, that is the absorber area. So area is more, so losses are also more. In case of concentrators, the receiver area is small, so the thermal losses are also low. Okay, so what are the components of the solar concentrator? This is the solar concentrator, one type of solar concentrator you can say, which is dual axis tracking. So the reflector, so this is the reflector which is made of some shining surface like mirror or reflecting films, and this is the receiver with smaller area. So whatever solar radiation falls on this, it is concentrated on this receiver area. Then the tracking arrangement, these concentrators need to track the position of the sun in order to get the beam radiation at all the times. Then the thermal integration system, the heat or the heated fluid which is coming out of this, it needs to be integrated with some industrial application or some application system. So the thermal integration system is required, and the other instrumentations and controls. So those are the components of solar concentrator. So what are the various types of solar concentrators that we will see? CPC type collectors, parabolic troughs, parabolic dishes, compact linear Fresnel reflectors, central receivers, or power towers. So 2/3 of the industrial end energy is used for process heat application, and 1/3 of the process heat requirement is below 200 degrees centigrade. So there is a huge potential for solar energy. So 1 million tons of furnace oil worth 3,000 crores is being consumed every year for new boilers added, and total furnace oil consumed in a year is around 8.5 million tons, which is worth 25,000 crores. That was the earlier price, but now the price fluctuation is always there. So every year that price changes. So these are the various popular technologies. Here in this case, parabolic trough concentrator, we get the line focus. So whatever solar radiation is falling on this parabolic trough, it gets converged on this focal line. And through this focal line, on this focal line, the receiver is kept through which the fluid is flowing. So the fluid which is flowing through this receiver tube gets heated, and it is ready to use for the application. Then another, this is medium temperature, and parabolic trough concentrator, here there is a point focus. So obviously the temperature which we receive at this end is higher. So the applications are different. Then this is the central receiver concentrator. Here there are multiple mirrors, like the area may be 2 feet by 2 feet. And all the mirrors are tracked in such a way that the focus is converged, the solar radiations which are falling on it are converged on the central receiver. So here you can get a huge temperature of 800 degrees or 1200 degrees centigrade, and mainly these are used for power generation, high temperature applications. So these are the three commonly used reflecting schemes for concentrating solar energy to attain high temperatures. So the CPC collectors, these are the only collectors which are non-tracking. These are almost like evacuated tube collectors, but the only difference is that below these tubes, there are parabolic concentrators. So whatever solar radiation, since the name only indicates compound parabolic concentrator, so there is a compound parabola. So it receives the solar radiation, these tubes receives the solar radiation from all the angles, even from the bottom of this tube, which was not the case for evacuated tube collectors. So this is the most simple and most popular technology in concentrating type collectors. So because of this arrangement, it is called as concentrating. Otherwise, it is also non-moving collector, non-tracking collector. Here you can achieve temperature up to 120 degrees. So it is most popular and working very nicely in industries. So I have worked in a solar company also, Thermax Limited. So we had installed almost 30 solar installations using various technologies. So we observed that this technology runs seamlessly without any problem in the industries, and it is well accepted because in other technologies, the customer or user has to take care of the tracking arrangement. He has to use the manpower for, and these the other technologies, they need continuous attention. So this is not the case with CPC collectors. So once installed, it only requires cleaning of these tubes, because if dust is accumulated, then the transmittance is low, so the performance is hampered. So that is the only maintenance required for mainly for these CPC type connectors. And another type is this parabolic dish, Shaffler dish. It is named after a scientist, Shaffler, who has developed this technology. And using this, these are the mirrors. This is the elliptical or parabola, you can say. So here also, whatever solar radiation falls here, in front of this dish, there is a receiver. The receiver is here, placed here. So whatever solar radiation falls on this, it is focused on this receiver area, and the water or fluid is flowing through this receiver area, which gets heated. So I want to show you the installation, how it looks like. Just let me try. Is it visible?
Yes, ma'am, it is visible.
Okay. So this is the layout of Shaffler dishes used in an industry in Pune, Mahindra and Mahindra. So around 70 such dishes, Shaffler dishes, are installed, and the application is cooling for their process cooling requirement. So the hot water which is required in the vapor absorption machine was heated by using these solar dishes, and this was the layout. And one more thing. So this way the tracking is done. You can see, of course, the movement shown here is fast, but it is very slow movement. The tracking is done in the east-west, and now it is showing north-south tracking also, depending on the seasonal variation in sun's position. So this solar radiation, the radiation which is falling here is focused on this receiver, and the fluid flowing through this gets heated. This is how it works. Okay. So it can generate up to 150 degrees centigrade. So the temperature requirement, where the temperature requirement is medium, you can use this. Many times this is popular for cooking application, but because for cooking you need pressure up to 2 to 2.5 bar. So these dishes are ideal for cooking application. For higher temperature, it may not work that efficiently. So this is the application mapping of solar parabolic dish. It can be used for in many industries like automobile, food, cement, chemicals, power generation. Power generation Shaffler is not that much feasible. Textile, hotels and commercial complexes, pharma industries and all. So the application mapping across the processes where temperature requirement is 100 to 150 degrees centigrade, these dishes are ideal. So this is also the photograph of the installation of Mahindra and Mahindra. Now this is showing the parabolic trough installation. So parabolic trough are the single axis tracking devices. So here the movement of this trough is from east to west direction depending on the movement of the sun throughout the day. So the parabolic trough can generate up to 200 degrees centigrade temperature. There are also many installations by various companies for various applications which demand temperature up to 200 degrees centigrade. So near Pune, there is a village, Shive village. There, these parabolic troughs have been used for solar thermal power generation. This is a hybrid plant and it is a solar thermal plus biomass plant for generation of 250 kilowatts of solar thermal power. When solar is not there, it is shifted on the biomass. The power from the biomass is used, and when solar is available, it runs on these parabolic troughs. So it is a huge area. Around 657 such parabolic troughs of 6 meters area are used here for in this installation. Another type is paraboloid dish. So these are the huge dishes. Usually these are used for high temperature applications. This is here the bus, and from this you can compare the size of this man with these dishes and you will get to know how big these dishes are. The area is 90 meters square. Some dishes are around 160, 170 meters square area also. Such big these solar concentrators are. So the parabolic dish concentrates the sun rays at a focal point propped above the center of the dish, and the entire apparatus tracks the sun with the dish and receiver moving in tandem. In case of Shaffler dish, the receiver is fixed, whereas in parabolic dish, the receiver also moves along with this dish. So most dishes have an independent engine or generator such as Stirling machine or micro turbine at the focal point. So another type is linear Fresnel reflector. Here, the long rows of curved mirrors are there to reflect the sun rays. Here there is a receiver tube. It is placed down this. It is facing downwards. So the fluid which is flowing through this tube gets heated. All these rows of mirrors converge their focus on this receiver tube. Then there are another type of solar concentrators. In India, Arun Concentrator is also very popular. It has an area of 169 meters square, and it can be used for the temperature applications requirements of 250 degrees centigrade also. So you must be wondering, at 250 degree, water must be getting vaporized or steam will form. So how these collectors are used for this temperature? So by using the nitrogen blanketing, water is pressurized. So it is not allowed to get converted into steam. And that hot water is used in vapor absorption machines or in some other devices. And or the thermic fluid is flown through these systems whose boiling point is 350 degrees centigrade. In India, Asia's first largest cooking system is in Shirdi Samsthan. So we were involved in installation of that system. It is working seamlessly since last 10 years, more than 10 years now. So these are the This graph shows the performance of the various technologies. This is single cover flat plate collector. So the efficiency will be higher at lower temperature, and then at higher temperature it suddenly drops down. whereas the non-concentrating, the concentrating collectors, the efficiency is lower. The efficiency is maintained even at higher temperatures. So using this graph, we can decide for which application, which technology to be used. So these are the various industrial sectors and processes with greatest potential for solar thermal uses. So for drying application, the temperature requirement is 30 to 90. For washing, 40 to 80. For pasteurizing, 80 to 110, and so on. So you know the process heat temperature requirement, you know the technologies. So these are the various technologies and these are the temperatures these technologies can generate. So you can decide which technology to be used for which application. It also shows the similar type, means like pharmaceutical industry, the temperature requirement is 80 to 230 and the working fluid is steam or air, like that. For laundry, what is the temperature? For cooking, what is the temperature requirement? So this potential is in industrial sectors, in hospitality sector, in comfort cooling, in community cooking. So we will not go into details of cooking load and all, but you need to know the cooking pattern, the cooking load to design a solar thermal system. So I will just explain you one or two schemes. So here these are the parabolic dishes. This is the receiver. The fluid, this is the feed water tank. The water is coming through this pipeline to this steam drum and it is flowing through this receiver. The receiver is hot, so whatever this water which is flowing through this will also get heated. It goes to the steam drum and the circulation is going on till 10 kg per meter square steam pressure is generated, and then this steam is given to the vessels. Here direct injection type cooking vessel is there and jacketed type cooking vessel is there. If you are cooking rice or dal, then you can inject direct steam, and if you are boiling milk, then you cannot inject directly the steam. So here the jacketed vessels are used. So steam is given to this jacketed vessel and the milk which is there in the inside pot, it will come to boil. So like this, and if sufficient temperature or steam is not generated, then there is a boiler which will be used as a auxiliary heating system and it is given. So in Shirdi or any other big cooking installation, such type of arrangements are there. In Shirdi there are 73 such dishes, Shaffler dishes, and they cook rice, boil potatoes or dal here, and they cook daily for 10,000 people, and they're using this steam which is generated from this solar field. Then another application is cooling application. So here there is a three-way valve. The hot water which is coming, pressurized hot water, it is given to the vapor absorption machine, and the return water also again goes to the solar field. In this way the circulation is going on. So this is the India's first comfort cooling at Solar Energy Center. Now it is named as National Institute for Solar Energy. Here they have used triple effect vapor absorption machine. This is for cooling application. This is indigenous development of parabolic trough and vapor absorption machine. Since it was installed by Thermax Limited, they are into cooling and heating business. So solar heating they have used, and for cooling they have used triple effect vapor absorption machine, and that is also being used there in National Institute of Solar Energy. So we have seen so far, these are the various solar technologies available to us. 1 minute. I'll have to mute the camera. Okay. The CST, concentrated solar thermal technologies, I have explained you all the technologies. So something which, how much time I have? Yeah.
Madam, better if you can wind up in 10 minutes so that 15, 20-minute discussion can be done.
Okay. So I will skip this part, but the integration is very important part. Now we know the technologies, we know the applications, and now we must talk about the integration technologies. So I have done here the comparison with PV, but now we will not go into details of that. If you look at CST, all these underlined points here are the advantages of concentrated solar thermal technology. What we need to do is, there is a wide variation. If you can see here, cost of CST, we need to make it viable. And if you cut down up to the 6.3 rupees per kilowatt hour, then we need to bring this back through this technology, how much cost we can reduce. So it is very clear that CST has good advantages of good efficiency and cost ratio, and most important, it needs the right integration technology. So first, let us understand what is process heat. Any industry needs heat in normally through boilers, oil heaters, or thermic fluid heaters. As per the analysis done till now in industries up to 250 degrees centigrade, a huge amount of fossil fuels is getting consumed, as well as lot of heating is done using electricity. Out of that, 10% can be substituted with solar, depending on the area availability, which is considered as a good amount. So one of the plus points of solar energy is energy security, because it will be always available to us, unlike other fossil fuels, and it is truly distributed. So with this in mind, how do we ensure that most of the energy from the plants get used, whatever is available to it? So the question is, why integration? In any process plant, the boiler is the most important utility. If the boiler fails, the whole plant will be shut down. If the plant is shut, the losses are huge. So there is always a standby boiler, because in industries, sorry, the industries can't afford shutdown. So 100% solar is not possible, because there will be fluctuation. There has to be a backup fossil fuel boiler. Second most important thing is, if I open the valves, the steam should always flow. If that doesn't happen, the process suffers. So use varies from 30 to 100%. For example, if I have a 10-ton boiler, sometimes you will use 3 tons, sometimes you will use 9 tons or 10 tons. You don't use exactly 10 tons. So these are the practical things. Sorry. The plant can be run, it can't be run 100% on solar. So the major concern is area availability. The solar radiation varies, so output will also vary. So we can have solar as a supplementary process heat, as a partial substitute to the existing system. So in industry, this is the boiler, the steam comes in, condensate comes in, makeup water comes in, and this is a pump. We give this hot water, we heat this water at 60 to 80 degrees, and then with the help of pump we give it to the boiler. So typical boiler feed water preheating is, solar field is isolated, different, and when the temperature reaches to 60 to 80, usually it is given to the boiler. But instead, we should follow such a practice that whatever solar heat we get, we should integrate or connect it in series with this existing boiler feed water. Then it will be more viable. That way we will be able to utilize whatever solar heat comes to us and the load on this boiler feed water through steam will be reduced. If you are giving solar hot water at say 30 degree, 40 degree or 50 degree, the rest of the heat will be compensated using this steam. So if you give it at 50, 60 degree rather than 25 degrees, so the load on this boiler feed water to get heated by steam will be reduced. So use whatever area is available, solar heat fraction only will vary. So I will not go into the details of these case studies. One more application only I will discuss. Solar power system. So we have seen the low temperature applications, we have seen the medium temperature applications. Now this is the high temperature application, that is for power. So uh, the conventional thermal power plants typically operate with steam, Rankine, gas turbine, Brayton cycle or combined cycle. It converts the chemical energy of the fuel, whatever the fuel it may be, coal, oil or natural gas, to heat, which in turn is converted into electricity using a suitable working fluid and a prime mover. So in case of solar thermal power plant, it uses the concentrating collectors, therefore also referred to as concentrating solar power, CSP plants. So solar radiation is concentrated on a receiver, then thermal energy is transported using a heat transfer fluid, and then it is transferred to power cycle working fluid. So basically there are three parts of this CSP plant. One thing we have to remember, it only uses beam or direct radiation. Then the solar field, it concentrates the incident solar radiation and transportation of thermal energy using heat transfer fluid. Then the thermal energy storage part, the storage of thermal energy for use during no or low sunshine hours, and the power blocks for conversion of thermal energy into electrical power. So here you can see in this schematic, you will notice that there are number of small blocks. These blocks are various parabolic trough collector systems. In parabolic trough power plant, several parabolic trough collectors are connected in series. You can see here. As we observe in the top right corner, which is denoted by the gray color, several such sets are then connected in parallel in order to collect the incident solar radiation. All such sets are connected in series, have the similar pressure drop and temperature rise characteristics, and these several sets of parabolic trough are connected to this power block. These are connected to the power blocks using supply and return headers. The blue lines indicate the supply headers and the red lines indicate the return headers. The supply headers shown in blue take the cold heat transfer fluid, which is typically a thermal oil, to the parabolic collector solar field, and where the temperature of this thermal oil is raised in the parabolic trough collector, and the return header is then used to transfer this hot thermal oil back to the power block, where it transfers the heat to the power block working fluid. And this is the typical schematic of this parabolic trough based power plant. So all this plant is as per the existing plant, only the hot water or steam which is required is provided through this solar field. Rest of the plant is same. So another type is central receiver CSP plant. So in this configuration, as has been previously explained, the solar radiation is concentrated using a number of heliostats or reflecting mirrors. The mirror reflects the incident solar radiation on a receiver which is placed on the top of the tower here. The thermal energy that is collected and transferred to the molten salt, which is the heat transfer fluid in such configurations here. The heat transfer fluid may be water or steam. In case of a direct steam generation power plant, here in the configuration, we may also see that there is a two-tank storage system where there is a hot molten storage tank and a cold molten storage tank. the thermal energy received by the heat transfer fluid or the molten salt in the receiver is transported to the hot molten salt tank from here to here. It is stored or it is sent to the steam generator of the power cycle, and in this case it is a simple steam Rankine cycle. So this is how these CSP plants they work, and you can see such huge installation it is. This tower is around 600 meters sometimes, and this involves certain very huge space in kilometers. So here, these are the buildings, so you can have the idea how big these solar installations are. So thank you. There are many other things also, but in one lecture, it is very difficult to cover all these aspects. So now, if you have any questions, please feel free to ask. Thank you, sir.
Thank you, Anaga, madam, for such a good discussion. So now the forum is open for questions. So participants, if you have any questions, please go ahead.
Usually, when we talk about solar energy, the installations which come in front of our eyes is solar photovoltaics, but very few people know that these are also the applications of solar thermal energy. So,
Naga ma'am, this is Swapnil here.
yeah.
Ma'am, wonderful presentation, quite interesting. Starting from the basics to a very well advanced applications. So ma'am, there are a lot of materials which have been used for making this solar panels. Like you did mention about mirrors and aluminium and some metals. So there's a. Do you think it is a good area of research which involves identification of suitable materials as well, or is it now more
In
of a
case of
secondary?
solar thermal, it doesn't matter much as long as the absorber is selectively coated, means it can absorb the heat well, that is fine. For example, in case of flat plate collector, the fins can be made up of aluminum as well or copper as well. There is some difference in the heat absorption or heat conduction depending on the material used. Of course, copper will perform better than aluminum, but in case of water heating systems, the temperature difference of 5 degrees doesn't matter much. But these materials, of course, in solar PV technologies, which will be covered by Dr. Adinath after my presentation. So there it matters what is the material used for the thin film depositions and all. But in case of solar thermal collectors, uh, the heat conduction is the important parameter. So there only mostly the material plays role.
Okay, thank you, ma'am.
Sorry, yeah. So, ma'am, I have a question related to that. So, I'll ask that, and I think there is one more question in the chat box as well. So, my question, something related to what you answered. So, let's say now you said because material doesn't play much role in the case of water heating application, right? But if you consider solar dryer application, right?
Yes.
Then, so does the same principle apply here as well? Like the material doesn't play
Here
much
also,
role?
because we have to trap the heat.
Right.
So the transmittance of the glass cover that matters in case of low temperature application. I'm
Okay.
talking about. So we have to trap the heat in case of solar dryers also. So the collector box is painted black, and mostly it is selectively coated, and the greenhouse effect is given to it so that the heat is trapped. So
Right.
that is the main part. But in case of concentrating type collector, the reflector properties are more important. How much
Right.
solar radiation is reflected back on the receiver. And then the receiver material, it also is important because the material of the receiver, how much heat it is capable of absorbing, that is important. But at the same time, the durability and the cost is also considered. So in case of thermal, if it is for process heat application, the temperature difference, as I told you, 5 to 10 degrees hardly matters. So
Okay.
it is not that crucial.
Okay. Okay. And like you said, for the transmitters, then obviously the glass material is very important, because for
Yes.
dryers as well, you need more and more transmitters.
Yes.
But if you,
So, yeah.
yeah. So my question was, but if you see, like, obviously, because you also said afterward that durability matters as well, because if you see the solar dryers available in the market these days,
Mhm.
so they use something called as these polycarbonate sheets for transmitters instead of glass. Obviously, that is because of the maintenance and durability, right?
There are different types of solar dryers available in the market, not in the market, in the research stage only. So some of them are using poly sheets. Some dryers are based on, like I have shown you, the natural convection and
Right.
the
Yes. Yes.
circulation dryers. But like for other products, for solar water heaters, be it flat plate collector or evacuated tube collector or even concentrators, there are certain standards which are issued by the Bureau of Indian Standards. But for dryers, we are in the core committee of that standard formulation. So now we are in the process of formulation of standards for solar dryers. So what should be the
Okay.
materials used? What should be the various components and its performance? So till now there are no standards available. So people use
Okay.
different types of
Right. Okay. Okay. Okay.
designs for it.
Okay. Okay. Thank you, Anagha ma'am. I will get back to you on this. So
Definitely.
yeah. So there's a question in chat box from Mr. Abhinandan, and he asks, which is more efficient for heating purposes, solar thermal or solar PV?
Of course, for heating purpose, solar thermal is more efficient because you are using directly heat. So, and also the efficiency of these solar devices is around 50 to 60%. The efficiency of solar PV will be higher for electricity usage because
Right.
in solar panel you are converting solar radiation into electricity which you are using directly. And if you have to use solar thermal collectors, then first you have to use the convert it into solar thermal and then secondary conversion into electricity. So some efficiency loss,
Right.
some heat loss will be there. So for
Right.
heating application, solar thermal is more efficient. For electricity generation, solar
Yeah.
PV is more efficient.
Okay, great. I think that was the second question as well, and which is more efficient for power generation, thermal or PV. So I think you answered both in the.
Yeah.
So there's another question from Mr. Tushar Kadam, and he asks, please explain the phase change material in solar cooking, whether it is practically possible or not.
For solar cooking, usually the low pressure steam is required, which is 2 to 2.5 kg or per centimeter square. So usually there are various devices which are being used. So if you are using solar concentrator, so the steam is generated using the solar concentrators, and this steam is injected in the cooking vessels. So you can say there is a phase change from water to steam. Uh, but for some cooking applications, they are using thermic fluid, like in Shirdi. There are big kadai they are using. So it is surrounded by the heating coils. So there they are using thermic fluid to heat the oil which is there in that vessel. So these there are various types of technologies which are being used. For community cooking also, these Shaffler type dishes are more popular than other technologies.
Okay.
But,
Okay.
yeah.
Thank you. There is another question from Dr. Bhatgujar, and he asks why the solar systems are not still used for domestic applications.
I didn't understand which for domestic application mainly the heating solar water heaters are very popular.
Yes.
Solar box type cookers are popular. Parabolic dishes, I think there is less awareness. Earlier, we had one energy park in our department where we had displayed these various solar thermal devices. But most of the people are unaware of these technologies. So that awareness, creation of awareness is more important. And through these nodal agencies like Maharashtra Energy Development Agency, and for other state also there are nodal agencies, they should promote these technologies and make people aware about this. So then the use of these technologies will be expanded, you can say.
Right. It is, yes.
Ma'am, there is another question by Dr. Bhat.
Yes, ask your question. I think I covered that.
Ma'am, may I have one query?
Okay.
Yes, ma'am, please go ahead.
Yes, please.
Excuse me, ma'am, I just want to know about that. There are 3 generation solar cell, as I have read about theoretically. First generation, second silicon chips based, second generation are from cadmium selenide based, and the third generation are dye sensitized solar cell as per the theoretical knowledge of mine. So which would one has to be installed, because after installation, I think the second generation are very dangerous.
I will interrupt here.
Yes, sir.
Because I talked about solar thermal technologies, and my colleague Dr. Adinath, he will be talking about the solar PV, solar cells and other things. So here we did not speak today or did not discuss about the solar cells or solar photovoltaic. This session was regarding solar thermal only. So maybe in the next lecture, next session, you will be able to get the answer.
So in solar thermal, which kind of cells are utilized? No, not at all. Only mirrors are utilized.
Yes, the receiver is, it can be, in case of water heaters, it is absorber coating or the absorber, and in case of concentrators, reflector, mirror or film that is being used. So no cells are used in case of solar
But
thermal.
absorbers are made up of something material, ma'am. I just
Yes.
want to know about that. Material are dangerous to use or not for
No,
future
these are, in
generations?
case of absorbers are made up of copper or aluminum. So copper, it is coated with selective coating, which has absorptivity of more than 90% and emissivity is very less. So only these materials are mainly used, and the collector boxes are made of aluminum or it can be made of FRP. That is not at all dangerous.
Okay, ma'am. Thank you, ma'am. Thank you.
Yeah.
Ma'am, there is one more question from Swapnil sir. Please share some light on ongoing research domains.
So nowadays, as the photovoltaic technology is very simple as compared to solar thermal technologies, because solar thermal, it requires tracking and continuous attention is required. Manpower is required to be engaged for the monitoring and tracking the collectors. So more focus. Also, the government policies support solar PV technologies more than thermal nowadays. So somewhat there is the solar thermal research has taken a back foot. Of course, we will see that in future when there will be stagnation of solar PV, what is to be done with this recycle, the material or the panels when they come for recycling? Are we ready for this recycling with the infrastructure of recycling? At that time, again, there will be the solar thermal technology which will take the boost. So at present, somewhat there is some back foot in case of solar thermal, because more focus of the manufacturers is also on the solar photovoltaic. Of course, there are various applications where still the solar thermal technologies are more feasible, but because of the subsidies and other government policies, nowadays more focus, even on the research, the more focus is in solar photovoltaic.
Okay, ma'am. Thank you.
But
Sanjay,
then
Mr. Sanjay.
receiver coating, then receiver designs, these are still the thrust areas of research in solar thermal.
Right, right. Yes, Mr. Sanjay, you can ask your question.
Hello, madam.
Please give some information about the selective coating material for different application.
Selective coating material mainly for flat plate collector, the nickel chromium coating is used. Of course, I am not from the material science, so right now may not be able to comment on the various materials which are being used. But the main thing is uh, there are very few companies which are doing this absorber coating. It is mainly required for flat plate collectors and evacuated tube collectors only. So mostly it is nickel chromium, what I understand.
Okay, thank you, ma'am.
Ma'am, there is another question from Mr. Abhinandan again, and he asks, regarding my previous questions, I want to continue with the intermittency issue. If we consider solar thermal plus phase change storage and solar PV plus battery for heating at night, which will be more feasible?
All this part will be covered in energy storage in the next lecture. But of course, if we put the systems which are complementary to each other, like for solar thermal or solar thermal and wind energy goes hand in hand, because when solar energy is low during the rainy season, wind energy is more efficient at that particular time or the season. So if we use the hybrid systems, that will be more feasible in my opinion. And we have done a study of wind hybrid solar systems, and throughout the year you can get the required output from the systems if you use these hybrid systems. And energy storage is also a topic of very thrust areas of research, but it requires huge area for storage, and it increases the cost of the system and overall cost of the project. So using these hybrid technologies is more feasible. Battery also involves cost and replacement after a few years.
Right. Okay, there is, I think, one more question. Ma'am, what about solar waste management?
In case of solar thermal, that is the advantage of solar thermal systems. So whatever material is used in solar thermal, it is very much recyclable. Like the structure, if you consider the structure, it is more made up of mild steel or galvanized steel or aluminum. So all these materials or metals can be easily recycled. The glass. So in case of solar thermal, the recycle problem is not there. So like solar PV cells, what is to be done, or like e-waste, the even you get income out of this solar thermal technology when you discard it through the scrap.
Right. Okay. Okay.
That is the
Thank you
advantage.
so much.
Yeah.
Yes. Thank you so much, ma'am. Okay, there is another question from Dhanishta. I think we'll take this as the last question because we are almost past 11 now. So there is one last question, ma'am. As you said earlier, as its installation is very costly, to use this technology on a large scale in order to reduce the light shortage in rural areas, do you think the government is doing enough to promote these technologies?
This technology, solar thermal, is not feasible for lighting application, as I already said. For various industrial process heat applications, cooking applications, this is very much feasible. And for medium temperature applications, government is giving subsidies on solar concentrators based on the per meter square area. So in many industries, these medium temperature solar concentrators are being used. Solar water heaters are already popular for domestic sectors as well as on hostels, hospitals, societies. But for electrification, solar technology is not feasible, street lights and all. For that, solar photovoltaic system is being promoted by government also.
Right. Okay. I think if there are no more questions, I think we can conclude the sessions. Thank you again, Anaga ma'am. It was a very
Thank
indeed
you.